Howdy, howdy, howdy. Today I want to talk about the method of elimination, also called the method of addition, for solving systems of linear equations. In this case, we have a system of two linear equations in two unknowns. I want to talk about also why the elimination method works. I'm going to use elimination more than addition because that's a more common word that we'll use. So here's the main idea. We're going to take one equation, modify it, possibly. In this case, we definitely will. And then we're going to use that to add something to both sides of the other equation that will cause one of the variable terms to get eliminated. So since we're going to be adding something to both sides of an equation, that's where the word addition comes from for this method. And since the goal is going to be to eliminate one of the variable terms, that's where the elimination version of the name comes from. Now, I did randomly generate the coefficients and signs in this system of equations, so the solution set is probably not going to look that nice. Maybe it will, but it's probably not. So just kind of FYI, don't expect the answer to just be 1, 2 or something like that. Okay, so if I refer to this right here as equation 1 and this right here is equation 2, that'll make it a little easier for referring to things. So here's what I'm going to do. I'm going to first multiply. I'm going to take equation 2. I don't have to. I could use equation 1 instead. But I'm going to take equation 2 and I'm going to multiply it by something so that one of its variable terms, 4x and minus 2y, one of those variable terms, when multiplied by this factor, turns into the additive inverse, or opposite, of the corresponding term in the first equation. So in particular, we want to either multiply the second equation on both sides by something that will cause 4x times that number to be negative 7y, or cause negative 2y multiplied by that number to be positive 3y, because those are the additive inverses of the variable terms in the first equation. I'm just going to choose the x term just because it's first. There's no real important reason for this. So the first thing I'm going to do is I'm going to find the number to multiply both sides of equation 2 by to get an x term that is equal to the additive inverse of 7x, in other words, negative 7x. So I have something times 4x equals negative 7x. Okay, well, I don't have a 4 over here on the right side, so I'm going to multiply it by something over 4. I want the result to be negative, and we have a positive, so I'm going to multiply it by negative. And I want the coefficient to have a 7 here, so my numerator over here is going to be 7. Let's go ahead and check this. So if I take negative 7 fourths times 4x, using the associative property of multiplication, this is the same as negative 7 fourths times 4 times x. 4 is the same thing as 4 over 1. 4 divided by 4 is 1. And so we end up with negative 7 times 1 is 7. 4 times 1, sorry, there is no 4 there. 1 times 1 is 1. And this is just a equivalent expression to negative 7x, which is what we want. Okay, so that means I'm going to multiply both sides of equation 2 by negative 7 fourths. Okay, so I have 4x minus 2y equals negative 12, but I'm going to multiply both sides by negative 7 fourths. That's one of the properties of equality. So if I do that, I'll distribute the negative 7/4. On the right-hand side, there's no distributing because there's no sum, so I'm just going to go straight into multiplying. Negative times a negative is a positive, so this is going to become 7/4 times 12. But we can simplify this a little bit. 12 divided by 4 is 3. We'll also be able to simplify on the left-hand side if we remind ourselves that for fractions here, we can put them over 1. And so again, we have a 4 divided by 4 is 1. Over here, we can divide 2 by 2 if we split 4 into 2 times 2. So then we divide that out, and we're left with just the single 2 over here. Okay, so finally, we're left with negative 7x, right? That was what we wanted. Plus, negative times negative is a positive, 7/2 y equals 7 times 3 is 21, and that would be 21 over 1, but we don't need to write that. We can just write it as 21. Okay, cool. Now, why did I want to do that? I told you that's what I wanted, the negative 7x, but I didn't tell you really why. Okay, the reason why is now what we're going to do is we're going to add this expression to both sides of equation 1. And if we add that, then 7x plus the negative 7x are going to equal 0, and we've eliminated the x term. But we're going to be sneaky about it. Okay? Let's suppose I thought of this as the letter A. Okay? And I said, I'm going to add A to both sides of equation 1. Well, what I would have is 7x minus 3y plus A equals negative 7 plus A. But I don't need to be calling it A, right? I know what it is. But I'm going to be clever in that on the left side, I'm going to use this expression, negative 7x plus 7/2 y, because that's what we said A is equal to. But on the right-hand side, I'm going to say, well, if there's an equal sign here, right, these two expressions are equal, then I could also say A is equal to 21, right? So over here, instead of adding A in the form of negative 7x plus 7/2 y, I'm going to add A in the form of 21. And the reason I want to do that is that over here, I have additive inverses, and so these are going to total up to 0. But over here, I don't have x's and y's that I can combine like terms with. So I want to add something over here that can combine nicely with the negative 7. In that case, I need a constant. So let's go ahead and do that combining of like terms. So I have the 7x and the negative 7x, which is 0x. Okay, so 0x, I'll get rid of that in a moment. I have negative 3y and positive 7/2 y. A lot of people have trouble adding fractions in their head, so let's go ahead and write this out. This would be negative 3 over 1 y plus 7 over 2 y. And in order to do that, you need a common denominator, so you'd multiply by 2 over 2. And when we get down below here, we'll continue with that. And then negative 7 plus 21 is 14. That's a nice one. Okay, so now 0x, that's just 0, so I'm just going to not write that anymore. Now I have negative 3 times 2 is 6. I should say negative of 3 times 2 is negative 6. 1 times 2 is 2. And then we have y. Then we have the 7/2 y. Okay, we can go ahead and combine these now. So this becomes negative 6 halves plus 7 halves. So that's negative 6 plus 7 halves. Y equals 14. Negative 6 plus 7 is is positive 1. By the way, I should emphasize that negative applies to the 6, not the entire fraction. So we end up with positive 1/2 y equals 14. And finally, if I multiply both sides by 2, I end up with y equals 28. Okay, cool. That gives me what y is. I need to know what x is. We can just pick any equation that includes the alternate version of equation 2 that we got over here. Okay, I'm not going to use that one. There's no reason to use that one over any other one. I'm just going to use equation 1. Okay, so 7x minus 3y equals negative 7. So 7x minus 3y equals negative 7. And so what I'm going to do is I'm going to substitute (28) for y in equation 1. 7x minus 3y equals negative 7. Okay. Okay, so we have 7x minus 3 times 28 equals negative 7. So we end up with 7x minus, well, if this were 3 times 30, it'd be 90. So that'll be 90 minus 3 times 2 is 6. So 90 minus 6 is 84. You should check my arithmetic on that. Make sure you agree with that. Okay, I'm going to add 84 to both sides. And that is going to allow me to have just x on the left, just an x term on the left-hand side. Negative 7 plus 84 is 77. So then I divide by x. Divide by 7. And so I'm going to end up with x equals 11. So this is actually a much nicer solution than it could have been, right? We could have ended up with something that requires a lot of decimals or a fraction with a nasty denominator. But even though it is a little bit nicer than we expected, we should still check it, right? So we're pretty much guaranteed it's going to work in the first one since that's where I just got it from, but it doesn't hurt to check. Okay, but I'm going to leave that to you. So you're going to check that 7 times 11 minus 3 times 28 really does equal negative 7. Okay, you should do that. But we'll do this one together. We'll check equation 2. So equation 2 was 4x minus 2y equals negative 12. Okay, so if I'm right, this should be a true statement. So let's actually check it. 4 times 11 is 44. 2 times 28 is 56. 44 minus 56 is negative 12. So we are good. So our answer to part 1 is simply the ordered pair 11, 28. That's the single solution of this consistent independent system of equations. There is a part 2 though. Part 2 was to write the solution set. That is actually really easy since there's only one solution. Our set only contains this one solution, so it's just the set containing this single ordered pair of 11, 28, and that's it. I hope you found this helpful.